You might be asking, what is a recursion and how can I make one? Well, as you already might know, helper methods are methods that are reused in other methods. But a recursion is almost the same thing, but instead of other parts of the program referring to it, it refers to itself. I'm going to show you what I mean by that. First things first, we're going to define a method named met. Inside the met method, we want to output hello. This is where the recursion starts. We are going to call met once again inside our method and end it there. We defined a method met and refer to it again inside the method. This is what a recursion is. By calling it outside of the code, what's going to end up happening is that we're going to have an infinite loop. In order to have a proper recursion method, we need to have met the following two criteria. A base case where we halt the recursion, in other words, an exit for our recursion, and a recursive call where we continue the recursion. For example, I showed you a recursion, but it misses our first criteria in order for it to be a proper recursion. Having that in mind, let's make a recursion program that fits our two criteria. For example, we're going to write a code that does a countdown that displays my first recursion done right. We're going to call this method countdown, and our argument is going to be called num. So let me write that down real quick for you guys. Countdown with an argument of num. Now that we have a defined method, what we want to do now is create a base case. In other words, an exit for our recursion. We're going to set our exit/base case to 0, where we're going to have the program return the following statement: my first recursion done right. So, first things first, we're going to create an if statement with a return. So, return my first recursion done right. If num equals 0. What this is telling the program to do is if by any chance during our countdown num is ever equal to 0, we want it to exit or return my first recursion done right. Let's have it print out the current num. In order to do this, all we're going to do is just ask for a puts num. After that, this is where our recursion is going to start. What we want to do is that we want to call upon our original method, countdown, and every time it's referred to, we want it to go down by 1. So in order to do this, what we have to do is refer to countdown and figure out what do we have to do to the argument in order for it to count down every time it's referred to. In this case, all we're really doing is just going down one time. So we're going to minus it one time. What this program is basically showing is that every time num is not equal to 0, we want it to output the current value of it. And then after that, we're going to call the same method and we're going to minus it by 1 all the way until num is equal to 0, where we have an exit or a return where it prints out my first recursion done right. So now let's break it up and let's see what it really comes down to and how it looks like. So let's say we do call it outside of the method countdown 3. What is that going to look like? First things first, our num right now is going to equal to 3. And just like we see in our program, it's going to see, does it equal to 0? If it doesn't, what it's going to do, it's going to print out 3, and then it's going to do countdown num minus 1, which in this case will be 2. So now our num is 2. Once again, the program is going to try to see, is it equal to 0? If it's not, it's going to print out 2 once again and do countdown num minus 1, which will make num equal to 1. Once again, the countdown is going to see, is it equal to 0 once again. If it's not, it's going to output 1, and it's going to do countdown num minus 1, making num equal 0. Does num equal 0 in this case? It does. Therefore, having our exit printout of my first recursion done right. My first recursion done right. Let me show you now how this looks like on the computer. Before we get started, if you guys don't already have the following debugging tools, Pry and Bybug, I recommend downloading it. They are great debugging tools to use in Ruby. Pry is almost like a sandbox made for Ruby, and Bybug allows you to get an in-depth view of how your computer is reading the program. So let's see how this looks on our computer. First things first, we want to open up our editor. All we want to do is just open up a new file and save it to whatever folder we want to. In this case, I want to save it straight into my desktop folder. Let's just simply write down our recursive code that we wrote earlier. So countdown with an argument of num. We wanted to return my first recursion done right. If num equals 0, want an output of num and from here, all we're going to have to do is just open up our terminal so we can go straight into Pry. But before we do that, let's figure out where we saved it under. In this case, we saved it under desktop, so we're going to change our directory to desktop and go straight into Pry. From there, we're going to be able to load up our file, which is called test.rb, and call our method countdown. As you can see, our countdown worked just the way we predicted it was going to look like in our previous notes before. It's going to count down 3, 2, 1, and the moment it reaches 0, it's going to print out that exit statement, my first recursion done right. Now that we finally see how a recursion works and looks on our computer, let's see how the computer actually breaks it down and reads it itself. So please follow with me. Now let's see how the program looks at this problem. What we're going to do is we're going to require Bybug and put our debugger inside of our recursive method so we can see how the computer actually breaks this problem down. So, and inside our method, we're going to have our debugger. So we already know that this program works perfectly. Since it exits exactly at 0, all we really want to do is just see how the computer actually looks at this program. So what we're going to do is we're going to load up test.rb one more time and do countdown 3, just so it can load up into the Bybug. And we're going to display num so you can kind of follow through with what's going on right now. So right now, our num is set equal to 3. What the program is doing, it's seeing does the num equal to 0. If it doesn't, it's going to move on and output num. From there, it's going to call num minus 1 to get a new num equal to 2. And then it's going to ask and see, does num equal to 0? If it doesn't, as you're following through on line 5, it outputs num, moves on to line 6, and now we have a new num, which is equal to 1. Once again, it's going to go to line 4, see, does it equal to 0? If it doesn't, it's going to move on to line 5, and finally move on to line 6. In this case, num does equal to 0, so it's going to stop immediately. It's going to stop at line 4. And as you can see, the moment I press next, it's no longer going to go to line 5, line 6, or any other line. It's going to stop at line 4. And we're done. Once it reaches 0, the code is done. Hope this video helped you have a clear understanding of recursion. Please stay tuned for my next video showing even more examples of recursion. Till then, bye world.